This conference will now be recorded.
Hi guys, so today we had fourth session of free 19C old architecture workshop. So today we will discuss about the database server, database instance, database files, and in database instance we have SGA, background processes. So all things we will try to discuss today. If it finished today, then we will finish it today. Otherwise, we will continue on second session. Okay. So as you can see in the diagram, Oracle database basically consists of at least one database instance and one database. So database instance basically handles the memory and processes, and database which consists of physical files, that is called as data files. And also old architecture nowadays called as non-container database or non-CDB database. Okay, so whenever database open and user is doing the transaction, so Oracle database uses several database files during its operation. Okay, so as for old architecture, single instance contains one database and one instance, and one-to-one relationship between the database and the database instance. Okay, and on same server you can install multiple single instance database, and there are separate database instance for each database. So, so you can run a different version of Oracle database on the same machine. So as you can see in the diagram, we had client application, or you can say client process, and then connect packet. So basically packet contains the SQL statement. Before sending the SQL statement, it will try to connect and it will authenticate it by operating system, by password file, or by username and password. So whenever a user is trying to connect to the database, so listener is a database server process. It receive client request and establish a connection to the database instance, and then hand over the client connection to the server process. So the listener can run locally on the database server or run remotely. Okay, so in the diagram you can see that user is connecting, and then user is sending the statements, and then packet in the form of packet, listener take it and connect to the server process, then server process access the database memory and database storage where files reside, and then it will process the SQL statement. So this is the overall picture of Oracle server. Got it, guys? Now, second picture is showing a database instance. So in database instance, I said that database instance is a set of memory that is called as SGA, and it is a set of it contains set of background processes, and we had three types of memory. Can anyone tell me, guys, what types of memories we have? Yeah, guys. One already I spoken just now. So that is SGA, right? Now next two memories, please, guys. Okay, perfect. PGA. Next, UGA. Okay. So SGA is the bigger one, that is system global area or shared global area. So by the name of shared global area, it means whatever the content in the SGA, it will shared among the users who are connected to the database. Got it? And the PGA is a program global area, and UGA is user global area. So memory, we will discuss separately SGA, PGA, and UGA in detail. So the background process basically operate on the data files in the database and use the memory structure to do their work. So database instance exists only in memory. So we can say database instance as memory as logical area, right? So and then Oracle database also creates a server process to handle the connection to the database on behalf of client program. So the main Oracle process is server process, which comes when user connect and user is executing any SQL statement. Then this server process is the main process which performs the operations of SQL statement. And we know that operations of SQL statement include parsing and running SQL statement and retrieving and returning results to the client program. So these types of server process we can call as foreground process. Okay. uh, any questions? So Oracle server, you can say, consists of database instance and database files, or you can say only database. Got it? Any questions? If you have, you can type it in the chat box. Then next is we have SGA. This is the biggest one in terms of memory. So whenever instance is started, your parameter files will be read, and according to your parameter files, parameter SGA will configure. Okay. So system global area or shared global area, which contains data and control information for one Oracle database instance, and all server and background processes share the SGA. When you start a database instance, the amount of memory allocated for the SGA. Okay. And it contains the first one, we can say, shared pool. So the compulsory part of SGA is on fixed line, if you see in the diagram, and the dotted line components are not permanent. Actually, you need to configure for that optional memory area. So for mandatory memory areas are shared pool, database buffer cache, redo log buffer, and fixed SGA. So this is the interview questions. You can say that uh, how many mandatory memory components in the SGA. So you can tell this answer. Okay. So first one is shared pool, and second one is database buffer cache. Third one is redo log buffer, then large pool, then Java pool, then stream pool. Okay. And then we had X fix SGA. Then in memory area comes in 12C, mem optimize pool is comes in 18C. And same way we can configure additional shared IO pool, and also we have extension of database buffer cache, that is database smart flush cache. So basically we know that shared pool contains two components. One is data dictionary cache, and another one is library cache. Okay. So many other things also there in the shared pool, like in 11G result cache is introduced, so that also be available, but you need to configure it actually. So the shared pool store parse SQL, PL SQL code, system parameters, and data dictionary information. And shared pool is involved in almost every operation that occur in the database. Suppose user is executing SQL statement, then Oracle database access the shared pool. So basically, data dictionary cache stores the definition of database object and their permission, and library cache stores the execution plan and store procedure packages and control structures. And result cache, if you configure it, stores the result of commonly used queries and stores the result of functions. Got it? And then come to second component, that is optional component in the SDA, that is flashback buffer. So when flashback database is enabled, the background process, which is called as recovery writer process, RWR, is started, and RWR periodically copies modified blocks from the buffer cache to the flashback buffer, and sequentially it writes flashback database data from the flashback buffer to the flashback database logs, which reside on the storage, okay, and which are circularly reused. So that's why it is in a circle shape. Okay, so that is flashback buffer. And then database buffer cache is the memory area that store copies of data blocks read from the data file, and a buffer is a main memory address in which the buffer manage temporarily caches a currently or recently used data block. So okay, so all user concurrently connected to a database instance share access to the buffer cache. Okay, and then extension of buffer cache is smart flush cache. It is an optional memory area for database running on Solaris or Oracle Linux. Remember this. It provides a level 2 cache for database blocks, and it can improve response time and overall throughput for both read intensive online transaction processing workload OLTP and for data warehouse environment also. So database smart flash cache reside on one or more flash disk devices, which are solid state or storage devices that use flash memory, and typically this cache is more economical than additional main memory. Okay, so it provides faster than disk drives actually. Okay, excuse me. Then come to redo log buffer, that is a mandatory component, and it is a circular buffer. It holds the information about the changes which are done by the user. Suppose user is updating any record, user is deleting any record, user is inserting any record, user is creating an object. So everything changes is happening. So the information which is stored is called as redo entries. So redo entries always stored in redo log buffer first, and it contains the information of DML statement, DDL statement, and internal operation. And these redo entries are used for recovery purpose. Okay, later we will discuss more. And then large pool. Large pool is again an optional area which we create to release the burden of shared pool. This shared pool has many components. Okay, so if you want to release the burden of shared pool, you will create the large pool, and in large pool actually user global area, that is the third memory component, which is used for shared server connection. It will be created when you are taking a backup through Arman. For that, large pool is used. when you are doing Oracle XA interface, where transaction interact with multiple databases. So on that time, it will be used. And when you are doing parallel execution of a statement, so whatever the messages generated, it will store in the large pool. Okay, so this is large pool. And then in memory area, which is an again optional component, sorry, that enables object. In object we had tables, partitions, and other types which will be stored in memory area. And in memory area is basically a new format introduced Oracle. The format name is columnar format. Okay, this format enables scans, joins, and aggregate to perform much faster than the traditional on disk format, which basically use raw format. Okay, raw format, sorry, not raw. So it provides fast reporting and DML performance for both OLTP and data warehouses environment. Okay, so this feature is basically used for analytic applications that operates on a few columns and returning many rows, rather than for OLTP, which operates on few rows, returning many columns. Okay, so that is in memory area. So it's very vast component. Almost Oracle documentation has one book for to study in memory area. Okay, so that is not the scope of this workshop actually. And then mem optimized pool, it is an again optional component which provides high performance and scalability for key based queries. So mem optimized basically contains two parts. One is buffer area and the hash index. So fast lookup uses the hash index structure in this pool to fast access to the blocks of given table. Okay, and you can permanently pin in the buffer cache to avoid disk IO. So the buffer in the mem optimized pool are completely separate from the database buffer cache. So the hash index is created when the optimized row store is configured, and it is maintained automatically by Oracle database. So again, it is another concept for query fasting and everything. So that is not the scope of this workshop. Then shared IO pool, which is a secure file, and it is used for large IO operation on secure file, large object, that is LOBs. Okay, so LOBs are a set of data types that are designed to hold large amount of data. So secure file is an LOB storage parameter that allows uh, deduplication, encryption, and compression. Okay, so that is. And stream pool is used by for data pump, Oracle Stream, and Golden Gate integrated capture and apply process. And stream pool we are not using, so not discuss about that. And Oracle data pump we use generally to transport the data between schemas, between table space, between database. Okay, and Golden Gate is also using for transmitting the data between Oracle to Oracle and Oracle to other database, vice versa. So that is another addition, another discussion or another workshop. Okay, and then Java pool. Java pool by name, it is used for session specific Java code and data in the JVM. JVM means Java Virtual Machine, and this memory pool is used in different ways depending on the mode in which Oracle database is running. Okay, and fixed SGA, it is for internal housekeeping area. DBA has no intervention on that. and it contains general information about the state of the database and database instance, and whatever the communication happen between the processes, so that information is stored over here. Okay, so that is SGA. Any questions? Then shared pool. So if you see, the shared pool had many components. I generally spoke two components, library cache and data dictionary cache. But this other components you need to configure. Okay. So that is what I can say. uh, this is the component which is responsible for caching various types of data. So it is stored shared SQL statement, PL SQL code, system parameter, data dictionary information, and this pool involved in almost every operation that occurs in the database. So suppose user is executing SQL statement, then Oracle access the shared pool. So first component, library cache, is a shared pool memory structure that stores executable SQL and PL SQL code, and this cache contains the shared SQL and PL SQL areas and control structure such as locks and library cache handles. So whenever SQL statement is executed, database attempt to reuse previously executed code. Executed code means execution plan. So basically execution plan will stored in the library cache for your SQL statement for PL SQL code. So if statement is present, then you server process will use that execution plan. If it is not, that is called as soft parse, and or you can say library cache hit. If suppose server process is not founding any execution plan, it will generate a new plan that is called as hard parse or library cache miss. Okay, clear? Say yes or no. Okay. Reserve pool. Reserve pool is a memory area in the shared pool that Oracle database can use to allocate large contiguous chunks of memory. So the database allocate memory from the shared pool in chunks, and chunking basically allows large object to be loaded into the cache without requiring a single contiguous area. So in this way, database reduces the possibility of running out of contiguous memory because of fragmentation. So you can say over 5 KB approximate. Okay, and data dictionary cache, which actually stores information about the database object. So we know that data dictionary is stored in which file? Data dictionary is stored in which file? Another question. It's morning, guys. Quickly answer it if you know. Data dictionary is stored in system data files. Okay, so that is system data file or system table space, whatever. Okay, so that is, and in if basically when you are executing SQL statement, suppose I am saying select a star from employees. So first it will check the authentication, whether you have the access of these objects, and then whether you have whether this employees table is present in that or not, whether all columns are there or not. So these all information is stored in data dictionary cache. So server process will access those information, and if suppose it is not present into the data dictionary cache, it will goes to the database files, that is system files. It will read the information and it will take a copy and it will put into the data dictionary cache for future SQL statement. Okay, got it. So this cache is basically holds data as rows instead of buffers. That's why we called as row cache also. Okay, and then SQL results cache, which introduced in 11G. So it holds the result set actually, and the server result cache contains the SQL query result cache, PL SQL function result cache. So that's why it reduce the performance degradation. Okay, so it will improve the performance, and good candidate for result caching are frequently invoked functions or frequently invoked object that depend on static data. So according to that, you can configure it actually. Okay, and other components you have, which includes enqueues, latches, information lifecycle management, bitmap tables, that is ILM, active session history buffers, and other minor memory structure. So enqueues basically are shared memory structure logs that serialize access to database resource. So they can be associated with a session or transaction. Suppose control file transaction, data file, instance recovery, media recovery, transaction recovery, job queue, and so on. And latches are used as a low level control mechanism used to protect shared data structure in the SGA. Okay, so like row cache object, library cache pin, log file, parallel write, etc. So these are the shared pool component. Can you tell me, guys, what is logs and what is latches? Anyone? No one? Guys, if you are not participating, so I will not ask questions. Locks on memory is latch. Eh? Okay. Latches is visible local instance memory. My question is different. You are answering different. What is lock? Lock. Basically, one line answer. Please remember that. Lock happens on the object like table, etc. And latches happen on memory components. Okay. So that is the one line answer for that. And later many things related to locks and latches, so I'm not going into that. Okay, no, sorry, it's okay. Now database buffer cache. So this is very powerful components which does everything. So how many types of database buffer cache we have in Oracle? 5, 3, okay, 4. That is use pin is the states actually. Dirty is the states of blocks. I'm not asking that. I'm asking how many types of buffer cache we have. See, we had one default buffer cache. Okay, that default buffer cache means it is used for default block size. So what is my default block size? That is 8 KB from 10G onwards. You can't change it. Okay, whenever you installed, you see in my practical 8K was unhighlighted, so we can't change it. Okay, so first buffer cache is the default buffer cache, which holds 8 KB block size objects. Okay, but we know that how many types of blocks we have actually in Oracle. First answer this. How many types of blocks we had in Oracle database? Guys, quickly answer, please. How many types of blocks? 4. Okay, 4, 4. We had 5 types of block sizes in our database, that is 2K, 4K, 8K, 16K, and 32K. So now again, the types of block size we had are two types. One is standard block size, that is 8 KB, and one is non-standard block size, that can be 2K, that can be 4K, that can be 16K, that can be 32K. Got my point? Okay, so the first buffer cache, which is the default buffer cache, which used 8 KB block size. Then non-default buffer cache or non-standard block sizes buffer cache, we have 4. So 2K, 4K, 16K, 32K. If suppose you want to create a table for 2K, so before creating a table of 2K, you have to create a buffer cache for 2K. Okay, then same way for 4K, the same way for 16K, same way for 32K. So now total we have default buffer cache, 2K buffer cache, 4K buffer cache, 16K buffer cache, 32K buffer cache, right? So total we had 5. Okay, but Oracle is not stopping here. Oracle is giving another 2 buffer cache, which is called as keep buffer cache. Okay, in the diagram you can see, and recycle buffer cache. So now total we had 7. Okay, got my point? Now by default, if you are not creating any buffer cache, you had default buffer cache. So for keep you need to create, recycle you need to create, 2K you need to create, 4K you need to create, 16K you need to create, 32K you need to create. Okay, now clear? Anyone has doubt, please ask me here. Clear, guys? Now come to the definitions of this. I'm coming to that. So default pool is the location where blocks are normally cached, and default block size is 8 KB. Okay, so the default pool is the only buffer pool, so that we will use. And key pool is basically we use to create for those objects which are frequently used in my database. So we will pin these objects into the key pool so that it will not flush out. and recycle is used for large object and for not frequently used object. So we will pin those objects into recycle pool so that we can release the burden from the default buffer cache or default pool. Okay, and non-default buffer cache and non-default default buffer pool, basically when we used to create table spaces of 2 KB, 4 KB, 16 KB, and 32 KB. Okay, so they have own buffer for execution of those objects which reside on these table spaces. Clear? And then we had the smart flash cache. So as I said, it is an extension of buffer cache, and it will improve the performance by having the database caches of these types. And when database requests data, the system basically first look into the database buffer cache. If the data is not found, then system will look into the database smart flash cache buffer. If it does not find the data there, then only it will go to the disk storage where my database files reside. Okay, so in this way it will execute the query. Got it? And now you can see in the diagram LRU list. So what is LRU list? Anyone had idea about this? What is LRU? Least recently used. Okay. And on one side you are seeing cold, one side you are seeing hot. So what is those? You had given naming. I'm not asking naming, Lakshmi. What actually it what is the purpose of this LRU in database buffer cache? Okay, actually LRU list has uh, hot and cold end. Okay, so whenever buffer is in the buffer cache, so their addresses will store in LRU. If that buffer is not used actually recently, it will goes to the colder side, and the buffer which is used frequently, it will goes to the hotter side. Okay, so so that is the mechanism of LRU. There is only one LRU in your database buffer cache for data concurrency and for data blocks concurrency. Okay, so yeah, MRU means most recently used whatever. So this is the when block will be flush when it comes to cold side. Okay, again if it is used, it will goes to the hot side also. So that's why arrow direction in both way. Okay, so this is the concept of LRU. So you can say LRU manage your database buffer cache. And the next, checkpoint queue. So what is checkpoint queue? Yeah, guys. Checkpoint queue basically contains the information of dirty buffers. So whenever server process, whenever dirty DBWR writes the dirty buffer, So it will read the checkpoint queue, which buffer or which blocks, uh, whatever you can call this, but better to call this dirty buffer. So which dirty buffer it write first, it write second, it write third. So from this list, it will help you to DBWR to write the dirty buffer in the serial of the blocks which gets dirtied in the database buffer cache. Clear, guys? Now, flash buffer area is the consist of default flash cache, flash LRU chain and key flash LRU chain. So without database smart flash cache, when a process tries to access a block and the block does not exist in the buffer cache, then block first will be read from the disk into memory, that is physical read. And when the in-memory buffer cache gets full, buffer will get evicted out of the memory based on your LRU mechanism. So with database smart flash cache, when a clean in-memory buffer is aged out, the buffer content is written to the flash cache in the background by the DBWR, and the buffer header is kept in the memory as metadata in either the default flash or key flash LRU list, depending on the value of the flash underscore cache object attribute. Okay, so the key flash LRU is used to maintain the buffer address on a separate list to prevent the regular buffer headers from replacing them. So thus the flash buffer header belonging to an object specified as keep tend to stay in the flash cache for longer. If the flash underscore cache attribute object attribute is set to none, system does not retain the corresponding buffers in the flash cache or in memory. So when a buffer that was already aged out of memory is accessible again, the system checks the flash cache. If the buffer is found, it reads it back from the flash cache, which takes only a fraction of time reading from the disk. So the consistency of flash cache buffer across rack is maintained by the same way as by cache fusion. So that is different concept. I'm not going into that. And because the flash cache is an extended cache and direct path IO, so it will totally bypass the buffer cache. So this feature does not support direct path IO. Okay, and system does not put dirty buffer in flash cache. Please remember that, because it may have to read buffers in memory in order to checkpoint them, because writing to flash cache does not count for checkpoint. Okay, so clear, guys? So this is the concept of this. Now redo log buffer. So as I said, redo log buffer stores the redo entries, and redo entries contains the information like on which type of statement you are firing, DDL or DML, and what is the type of object, whether it is a table or index or materialized view. Okay, and what you are doing, you are updating, deleting, inserting or creating, and what is the SCN number before the execution of the SQL statement, and what is the SCN number after execution of that SQL statement, and if you are updating, so what is old value, what is new value. Okay, so like these information will be generated, and that all collectively information is called as redo entries. So for every transaction of in your database, redo entry is generated, whether it is a SQL statement, whether it is a DDL, whether it is a DML. For every SQL statement, redo entries will be generated, but the size of redo entries will depend on what type of operations you are performing. If you are performing only select query, it will minimize the redo entries information. When you are performing DDL, it will more in redo size. When you are performing DML, it will more in performing in the terms of size of redo entries. Okay, and after that, from redo log buffer, it will goes to the redo log files, and the process is LGWR. We will discuss later. Okay, so this data will flush out on certain condition. When your redo log buffer get one third full, it will flush the data. When your redo entry size become 1 MB, it will flush the data. When you had checkpoint, it will flush the data. Okay, so that are the condition of that means main condition I am talking about. Then large pool. So large pool is basically is very biggest in terms of size, because it holds many things. In the diagram you can see that, so you will get confused. So large pool has free memory, large pool has IO buffer area, large pool has request queue, large pool has response queue, large pool has UGA, that is third memory component, and large pool has deferred insert pool. So these component reside in the large pool. So can anyone tell me uh, what is the purpose of large pool? Yeah, it is also called write list. Whether you can say checkpoint queue or write list, you can say. For Arman backup. Okay. Okay, already we said that large pool basically release the burden of the shared pool. So if large pool is not there and you are using shared server connection, so UGA will configure in the shared pool. So when large pool is available, the UGA will configure into the large pool. So that is the first thing which is used by the large pool. And second, when you are taking a backup, then RMAN information will be stored over here. And when you are accessing other transaction, XA transaction, you can call it as Oracle XA interfaces and all. So for that it is used. Okay. So user global area is used for session memory for the shared server, and Oracle XA interface, okay, where transaction interact with multiple databases, and IO buffer area is for IO server process, message buffer used in parallel query operations, buffer for RMAN IO slaves, and advanced queuing memory table storage, and deferred insert pool is the this feature enables high frequency single row data insert into database for tables, and it is defined as mem optimized for write. So when you use that feature, then on that time this comes. And the insert by fast ingest are also known as deferred insert, and they are initially buffered into the large pool and later returned to disk asynchronously by the SMCO process, SMCO, Space Management Coordinator. And it has also WXXX slave process after 1 MB worth of writes per session per object or after 60 seconds. Okay, so any data buffered in this pool, even committed, cannot be read by any session, including the writer. So until the SMCO background process sweeps. So this pool is initialized in the large pool at the first inserted row of mem optimized table. So mem optimized table, if I'm using mem optimized table feature I'm using, then it comes. So don't go into that. Actually, we are not using in this workshop. So 2G is allocated from the large pool when there is enough space. If it does not have enough space in the large pool, then aura 4031 is internally discovered and automatically cleared. So allocation is retried with half the request size. So if there is still not enough space in the large pool, the allocation is retried with 512 MB, then 256 MB, after which the feature is disabled until the instance is restarted. So once the pool is initialized, the size remains static. It cannot grow, it cannot shrink. Excuse me. And free memory means not using for actually, so that comes free memory part. Now large pool has uh, used in shared server connection. So when you had a shared server connection, so how large pool will be used? So you can see in the diagram there is number 1 2 3 4 5 6 7 number you are seeing, right? So I'm residing. You can match what it is going on. So whenever you had a shared server environment, so where server process will not take the request from the user. So which one will take the request from the user? Which component? Which process? Can guys anyone tell me? Another question. I think 8 question. Yes, correct. Dispatcher. So if you can see in the diagram, the first number is saying client is sending the request. So dispatcher will take the request and dispatcher will place this request in request queue area, and from request queue area, shared server process whichever is free for your database, that comes and take the request, and you can say pick up the request, and then it will solve those requests and it will take the result. You can say retrieves data, and then it will place those result into response queue area, and from response queue area dispatcher will take the result and it will return to the user process. So this is the way your query is executed. You got it, guys, or should I repeat again? Okay, thank you. Very late reply. Okay, is there any operation you didn't check my installation, Biswajit? In that when we choose memory component SGA, in that we had dedicated connection and shared server connection, so we choose dedicated, right? So on that time we can do that. Now in memory area, that is not the scope of this workshop. So only I'm just telling that it is an optional SGA component that contains in memory column, which is store basically tables and partition in a columnar format. Okay, for rapid scanning. Okay, so generally we use to store data in row format, but when Oracle introduced this in-memory area, so they said that we stores the data in columnar format, which gives a better speed for OLTP queries and for data warehousing also. So you should add in-memory attribute for an object when creating or altering. Okay, so then this memory components will come into the picture. Okay, So I'm not going into more into that because it will confuse you guys. Okay, so yeah. Okay, so I am stopping here because today we had done too much theory. So if I will go with more, so it will be hard for you guys, those who are fresher. Okay, for experience, no matter. Okay, so yeah, guys. So if you have any questions, please ask, and I'm stopping the recording.